Awesome.
Okay, perfect. Okay, so the first one, what is the research question? I just put, do different cultures or genders affect the age of death among writers?
Yes.
I don't know. These first couple questions, I kind of just like hurry through. Um, okay. So then state the null and alternative hypothesis. I actually didn't even check to see if my answers were right. So I put the the null HO is all means are equal. Is that right? I didn't even check these.
Yep.
Okay. And then the alternative is uh, hold on.
At least one is different from the others.
Yeah, one or more of the means are different from the other.
And I think that's always going to be the null and the alternative for problem.
Yeah,
Multiple literal means unknown.
yeah, I think you're right. So, okay, then the next one, describe the data collection procedures. I just said 3 categories of writers were investigated. There wasn't really any, like, anything else to go from. So,
Well, I didn't really know what they were looking for, so I looked at the answer and it says we don't know how it was collected.
yeah, it's weird. Good
Yeah,
question.
that's yeah.
So, okay. And then I didn't write a short paragraph. I just made sure that I had the same answers that they did, like for on my chart, so I knew that I did it right. And
Yeah.
I did. So it was like I think the N was 67, 32, and 24, and then the mean was 71.448, 63.118, or 188, and 36.875. And then I don't know what those last numbers are. I don't like how they don't have the right symbols. But I had them all right. So that's really what I just wanted to make sure.
Okay.
Okay, you want to go for it?
Number 5. I couldn't get my printer to print out the questions, so I went by the questions on the computer and wrote them down, the answers down. So I hope this matches what the question is. Number 5, I just put down ANOVA for several means.
Yeah.
Yep.
And then for 6 are oh my gosh, I can't read my writing. Is the requirement met? SRS data is normal, and run the QQ plot. Analyze. You go from analyze to descriptive to explore to age and type. And yes, the plots were normal.
Yep.
Number 7 is 17.297 is less than 26, and so it passes.
Yep.
And number 8 is the F statistic is 6.563. And number 9, the degrees of freedom, which is a new thing that we've got 2 of them now. One is 2 and one is 120.
Yep.
And then number 10, p-value is 0.002, which is less than 0.05. So I guess that passes.
Yeah.
And so in 11, we reject the null. If the p's, I was just reiterating about the rule. If the p is low, reject the null. which we did. Then number 12, so we have sufficient evidence to suggest that there is a difference in at least one of the means of female riders' deaths. And then 13, the take action thing is we don't know which one is different, and that I think he said on the video that we should be careful drawing conclusions with ANOVA.
Yeah, that's what I understood too.
Okay, you want to finish up?
Yeah, hold on. My computer froze. I can't open it up.
That always happens.
I think I have too much stuff open. I was trying to open the SPSS, so it's like frozen.
That's all I
Is
have.
it just the last question?
I think that's 14, 15, 16, and 17.
I think we're done.
Oh, are we? Oh.
I didn't have any more written down after that.
I don't have any.
Well, what is it that I have here? I have something about a histogram.
What do you have? Because I don't have any of that.
Let's see. I have the last one is the take action. Yeah.
That's what I have for my last one.
What significance can you conclude from this, which is what you just said? I don't know what you have.
I don't either.
I don't know. Maybe I was just making notes on something, and I kept numbering everything. I think.
Maybe it's part of the quiz. Did you write some stuff down for the quiz?
No, I've got that on a separate page.
Oh, okay.
Okay, well, let's get to the quiz then.
Okay. My computer's being so slow, you guys. I'm trying to copy all this from Excel because I thought I could get it to work, but I can't. So I'm copying it and I'm gonna paste it. I can start with the first few questions.
Oh man, my quiz just booted me out.
Oh, why?
I don't know. I was trying to answer the first two questions that I saved for when we're doing together. And
You saved all your other questions?
I did.
Okay.
And I was trying to save the first two questions, and it booted me out. I'm getting back in, though.
Yeah.
And it took all the questions. It took all my answers. Even though I had saved them. Holy cow.
Are you serious?
But you don't have any answers?
I have no answers.
Oh, no. That's okay. I
Well,
was going to say...
I've got most of them written on a piece of paper, so that's my fallback, but this is frustrating.
Yeah, that's so weird.
Oh, whoa, wait a minute. What? This is very weird. I'm not in the right quiz. Why did it bring me back over here? All right, hold on.
What quiz are you in?
Number
I did-
15.
I've had this quiz open, this lesson 14, for a whole week because I accidentally did this one. Let's see, like my grades or anything because I didn't want to actually do this in a minute.
I thought about
I know.
Okay, all right, it's got my answers.
Oh, good. That's good.
Now let me see if it'll let me answer these first two and let me save them, and I'll be good to go. Yeah, it's doing it. Okay, let's go.
Okay, question 3. In ANOVA hypothesis test, we reject. That's the null, right? HO.
Yeah.
when there's sufficient evidence to indicate at least one mean is different from others. And I said that's true.
Yes, that's what I said.
Yeah, me too.
Okay.
What requirements need to be checked when performing an ANOVA hypothesis test? First one, sample means are all positive, and the last one.
I did the second one and the third one.
That's what I did, because I actually think that all the sample means are all positive is actually the F. So I was confused because it just says that for the F distribution, and then the F distribution, is that different than the...
I thought they had to be positive. I thought somewhere it said that they had to be.
It did,
Well,
it did for the F distribution, but it didn't in the requirements. Like, I wrote all of the requirements.
In the hypothesis test?
Yeah, and it didn't say that in the requirements for the ANOVA.
That could be right. And then the data in each group are normally distributed.
Yeah.
But I
So
thought
it just says, though, this is a little, I don't know if it's trying to trick us, though, because it says the populations have the same variances. And so that, I guess that variances are equal in each group, right? And then it says, let's see, the data are normally distributed for each group. So that's, yeah, so it's those last two, I think. It doesn't say they have to be positive in here.
where'd you read that in the book?
In the video that he did, like in part of the text video. So
Okay.
he, at the very end, he gives the requirements for ANOVA procedure, and this is, I just wrote them all down.
That makes sense. I'll look at that again. To check if each group is normally distributed, do the following. I said construct a Q plot.
Yeah, that's what I said.
Yeah.
6, we assume the variance in each group is the same if the following happened. Largest sample mean is less than 2 times the smallest sample mean.
This one really confused me because I've seen and read both and it must apply to two different things.
What's the other one you seen?
Because I've also seen or read that the largest variance is less than 4 times the smallest variance.
That's what I put, because when he kept doing it, he kept saying something about dividing it by 4. And so I put that.
I never heard that, but maybe it was something I missed.
I think those are two different things they're talking about, and I don't know it well enough to explain it to you.
I just remember when I would do like the big S has to be less than 2 small S's. Or is that not the variant?
Is that the F? So it's confusing because there's also the F value, which I don't even really know what that is. I mean,
I just assumed it was the variant, but I could be wrong. Let me see. I don't know. I didn't hear the 4 times thing anywhere.
The one that's 2 times is in the video he kept doing that the big S.
No, I see it right here. It says the requirement is checked by examining the variances. The rule we use is if the largest variance is 4 times the smallest variance. So you guys are right, but I missed that.
okay. I didn't know, like, what. I knew he kept doing it divided by 4, and I didn't know why. So I just put that.
But then he's got that piece on the video where he keeps putting the big S is less than the little s squared.
And that's why times.
It's confusing.
That was confusing.
But that would be different than 2 times because squared isn't.
It's yeah, I think it was just 2 times to the number.
Oh, I see. Okay. Weird. I wonder what that's all about.
Okie dokie.
Okay, well at least we got that clear.
Confusing than I thought.
Yeah. Okay, so
Question 7, is that another trick question?
that's what I thought. I'm like, 4?
Just said if there are 3 samples, there's 3 pairs. If there's 4 samples, how many pairs? 4?
That's what I thought.
I had to set it up and actually pair them together, and when you actually pair each set together, you have 6. Like,
so
like if you've got 4, you're going to put group 1 and 2 together, 1 and 3 together, 1 and 4 together. Then you're going to you keep doing that until you've covered them all,
Yeah.
and there's 6 of them.
yeah.
Let me see if I've got it written down.
But I didn't know 3 pairs.
Yeah, so here it is. I've got it written down. You've got 1 and 2, 1 and 3, 1 and 4. Then you've got 2 and 3, 2 and 4, and then 3 and 4.
What about 3 and 1?
3 and 1 comes under 1 and 3.
Oh.
I did all the 1s, and then the 2,
Yeah.
and then the 3, and it covers them all.
Okay. Well, that's confusing. So why? So there are 3 pairs: 1 and 2, 1 and 3, 2 and 3. Okay. 6. I think I believe you.
Here, I don't know if you can read this. This is how I have it broken down up there.
No, that makes sense. It's just like that's
I was just it was easier.
yeah.
It seems like there should probably be a mathematical way to figure it out. Maybe there is.
There is, and I've heard it before, but I forgot. Like it's me from like previous classes, but I don't remember.
Yeah, me either. Okay, well, thank you for writing it all down for us. Because I was like, that's a trick question. Or I was
That's what I was thinking too. She's like, no, it's not that easy.
So that's one that really was not too easy to be true. So, okay. Now we're on.
The next one, I didn't know how to get the minimum.
I
Because-
didn't either. I'm like so confused by that. So I guess I didn't know if that was oh, now I don't have it pulled up.
Is it just the smallest minimum in the whole the data?
It's the smallest. It's the smallest, but then you have to square it. It's the SD. What's the SD?
Okay, hold on. I gotta pull this up again because I don't have it.
Is it deviant? Not.
Standard deviation?
Yes, it's the square the standard deviation. So you take the smallest, which is 5.216.
Standard deviation?
Yeah.
Why did I have all this? I don't even remember this.
I didn't learn any of this.
I've had to really dig.
Okay,
This-
hang on. I'm trying to pull it up because I don't have it anymore.
Minimum smallest variance for the 6 groups. The smallest standard deviation?
And it's
square it?
5.216. And when you square it, that's the smallest, then you square it, and you come up with 27.208, I think. Let me double check
Oh,
that.
wait, yeah. I missed that one too. Oh, I really need to study for this test.
5.216 squared is 27.2. Well, now I got 206656, which you would go.
I put in all of the numbers from the data.
Okay,
27.2079.
wait, what did you do?
I don't know if this is right. I didn't even know how to do it. But I took the smallest standard deviation in the whole data set, squared it. But I think you have to plug in all the numbers, not just round it.
Oh, so what did you get?
I got 27.2079.
So then it's 27.208. Right?
If that's how you do it, I don't even know.
All right. Well, I hope it's right.
We'll check.
So then the largest one is going to be 7.291 squared.
Wait, you guys, go back. So what did you get for the lowest?
Do you have the data set up, like the descriptive data set up in SPSS?
What is your answer?
27.208.
208. So how did you get that?
You squared the smallest standard deviation.
So isn't that 5.216?
Yeah, and you square that, but you have to plug in the 2161 more accurate.
You have to like click on it more.
Oh, I just plugged in all the numbers that I saw before, whatever.
Sorry, what? Because I got, like, when I square 5.216, I get 27.207.
Yeah, 79.
No, it's 27.206656. So I rounded it to 27.
Did you plug in the whole 5.212? See, 5.21612, and I squared that.
Where'd you get the one?
It's just on my description.
When you double click on this on the number, it brings up the whole number.
That's what I'm trying to do. Oh, there it is. 5.216119. Okay, now I got it. So it just, I needed to, sorry, I didn't have that whole thing, so it didn't make any sense to me. So why are we squaring it? Do you guys know?
No.
That's what was in the video that confused me on that other answer, because it's two separate things. This is what you're needing to square for. And I was thinking that that's what it was asking for, where it was saying whether it was 2 times or the 4 times.
I don't even remember this in the video.
I don't.
Jamon.
I didn't either, and I wrote down like all my. I wrote down tons of notes. Okay, so the next one. Did you already do it?
I
So
got
it's just the large.
it was 53.15. Oh man.
158.158.
158.
53.158.
53.158. Yeah.
So
You're squaring 7.291 or 290946.
Uh-huh. 53.15789,357. And so just
Yeah,
round it to 53,158.
53158. That's what I got. Okay. Well, I'm glad you knew how to do that because I had no idea. I'm like,
Well, I hope it's right. I hope it's correct, that I'm remembering something correctly here.
and I remember.
So then
Yeah.
I'll have to
Me
go
too.
back and see if I can find it and let you know where I found it.
Okay.
All right, so number 10 then. So the test for equal variances is satisfied for these data. Is that true or false? I put true.
Okay.
I don't even understand what that's saying.
I know I put false, but I don't know why. I wasn't sure how to check that.
Because, hold on a minute. Let me see if I can figure it out.
I just thought,
I thought it was the whole you times the second by itself, and if it's then the
see, I thought
biggest.
it had to be less than 4 times
Oh,
the lowest. I thought that because so
talking about variances.
it says the largest variance is less than 4 times the smallest variance, which it is, right? Yeah.
Wait, okay, what was the rule again?
That's right. So the largest is 4 times the smallest.
No, it's less than 4 times the smallest.
So that makes it true.
Yeah.
Right.
Is that, I mean, is this right?
If these are right.
Okay.
So the
So then-
largest has to be smaller. Is the smallest?
Yeah.
Okay. Okay, I did not construct a QQ plot.
I did, and it was normal.
I did too, and it was normal. So it says for each example, did you guys only
How do you?
have one QQ plot? Because I only had one QQ plot. Well, there was 2, but one was a weird one.
I know it
So
has.
how do you?
The weird one is what's the name that they put on it? A label. It started with a D. Detrended,
Yeah.
and the detrended
So where
one
do
is
you-
way out of whack.
Yeah, so you just go off the other one, right? Okay, so Amory, you go to and
Analyze.
yeah, descriptive statistics, and then QQ plot, and then. So did you put in both of the variables?
I think I did it both ways. I think I did them both at the same time, and then I did them one at a time.
And then just normal. Do I have to do anything else?
I did it.
No, I think that was it.
Let me see.
So it looks normal on there, and that's why I said yes.
It didn't come up for me. Oh wait. It took
It takes it a second.
Scroll all the way down.
a second. Okay.
And it's
Yeah,
got the
I see.
detrended one first, and then second, and the normal one first.
What is the detrended?
I
one?
don't know.
Oh, I think that's if. So do you remember? He had to organize them a certain way to get them to line up. Well, that looks different. I think one's like lined up a certain way. Because I remember one of the first videos, he had to organize it a certain way to get it to line up. because it automatically like didn't organize in a certain way or something.
I don't know, but
I don't know.
since there's a normal one there, I don't worry about the detrended one.
You just see the normal one.
Yeah.
Kind of what I was thinking.
Okay.
I don't know. I
Um,
thought the reason he had to set it all up different, I thought he had to do the automatic recode to fix it. I thought,
I
don't
even
remember.
which I did, but I don't know. I really don't know. Okay, we'll see what we get right.
yeah.
Yeah,
Uh,
this is nerve-wracking.
12. So we're gonna say true on that one, right? Okay, and then 12.
Yeah.
Perform an ANOVA test. Okay, this one I didn't know how to remove the stocks data.
You know what I did?
What?
I just went in and deleted that column and then went back and analyzed it, and it brought me up a different p-value.
Yeah.
Oh,
So just leave that
but
done.
where is that the one we delete?
The
The socks one?
I don't have the one that says socks. I just have one that says footwear. Oh,
no, mine says, question 12 says, then remove the socks data.
what socks?
So in SPSS,
After you go past A, B, C, D, E, socks is the last one after E.
Okay, hang on. Are we still on the soccer shoes?
Yes.
yeah.
Because some people kick them in socks or barefoot, you know?
Yeah, but I don't.
I guess that's why they have socks in there.
I just don't see socks anywhere.
Go down past E. It's number 101.
Here, wait. Are you guys on like the sheet, the first thing that pulls up?
Yeah,
Okay,
I am.
where? I don't know what you guys are talking about. Wait. Okay, wait. Mine is like, do you scroll down
Yes.
and there's like a whole bunch of socks?
Yeah.
So you just take all of them out?
I deleted, I didn't take the word socks out. I just deleted the numbers that were there by each one, and it brought me up the different
I
p-value.
deleted all of the socks data, including the socks.
Deleted all of it, even the words.
Yeah, what did you get?
Why won't it delete? Oh, there we go. Okay, hold on. I'm getting it. How did you know how to do that? How did you know to do that? Or did you just guess?
I mean, I just fooled around with it.
It just says remove the socks data and perform the test again.
I didn't know if it would actually hold it and make it happen or not, and it did.
Good. Okay, that makes sense. Okay, so then you have to do a whole nother like analyze.
Do the analyze, and you'll come up with the p-value used to be 0.81.
Can you
Yeah.
still use the same recode, or do you have to do a whole nother recode?
No, it keeps the recode.
Yeah, I didn't recode it.
Okay, so analyze, compare me, one way. Okay.
And the answer I got was 0.309.
Okay, me too. Cool.
Yep, that's what I got.
Awesome. All right, so then go to the next.
Start.
Number 13, the test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of this F statistic? And I said to the right.
That's what I said.
So is that because, how did you know that?
Because isn't it right skewed? All of them are right skewed.
Yeah, in the video, they said they're all right skewed and it's all the far right data.
Okay.
All right, this next one is the one that I don't like.
I didn't even get to this one. Okay, I'm gonna copy all the data into SPSS. Hold on. You
It
can
says-
keep going.
Let's examine the calories. Construct the QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met. I put number 1, the assumptions have been met. It's safe to assume each group comes from a normally distributed population from the QQ plots. And we can also assume that the variances are equal.
That's what I put too.
So you just constructed the QQ plots and they were normal?
Yes.
Okay. And then you can assume all of that.
I mean, I guess it's safe to assume from that. That's. Oh.
That's what I guess.
And then the next one, I hope this is right. Number 3, the third answer, we have sufficient evidence to claim that all 3 hot dog types have a different mean number of calories.
See, I put the last one because the alternative hypothesis says that it just says that at least one of the hot dog types has a different mean. It doesn't say that. It doesn't mean that all of them. Did you put anything in that, Emery?
No, I didn't. I didn't even get this far.
Because
Although it did say that it's not safe to assume that the variances are equal.
So you should,
So I'm going to change mine to number 4.
well, can you just, with the data that's there, assume? Because the p-value is 0.000.
True.
So then if it's low, if you reject the null.
yeah,
So what's the null?
the null is that they're all. Hold on, let me find.
Okay,
exactly
so the
what-
number
all the
4 would make
same.
sense. Yeah. So obviously, yeah, the nulls are all the same. And then so if we reject that, so then there is, yeah, I think I see how it's number 4.
So then it says so.
At least one. Yeah.
For these, it says so. Yeah, because right here it says in an ANOVA. The
Yeah,
null.
I remember we don't know which one is different. We just know that one of them, or at least one of them,
Yeah,
is different.
one or more.
Yeah.
That's
Okay.
why I put that. I don't know.
Yeah, I
if
think
that's
it's
right.
number 4
That's just
for
why
sure.
I put that. Okay.
I agree.
All right. So I changed mine. Then there's number 16.
Did you even do anything for these, or is it all in the question?
I think it's on the question, but I was kind of thinking maybe I should do it and see if we did it right, because it has the lowest and the highest, and we should check and see if we did it right in that first question.
Yeah. Yeah.
Like if it's the standard deviation squared,
Yeah.
and then see if our numbers match. So I'm going to pull it up really quick because, wait, do we even have this? Oh, yeah, we do.
I'm gonna try. But I have to convert it all over from Excel.
That's a lot of work.
Yeah, it's annoying. Sometimes it works and sometimes it just, I don't know why.
I hate these ones with the assumptions and sufficient evidences.
Okay. Yeah. So I need to recode really quick. Okay, analyze here. Oh, what are we doing though? Calories or sodium?
Yeah, that's why I'm wondering with the two variables. You doing both?
I think I did both when I was working them.
It's doing both. It's talking about both. So let's try both.
Yeah, I'm still trying to copy them. Almost there.
Although the last question,
You have to do that.
question number
I know.
16 is about the sodium.
Yeah, but I think this one is asking about both calories and whatever. Okay, so the lowest one. Sorry, my family starts texting at like midnight, and I'm like, go away.
Okay, I finished. So you are just looking at,
I'm just trying to see if we're right of how we do it. So for the lowest, what does the lowest say? I think you're wrong.
so you put both of them on the dependent list? Oh shoot, I forgot to pull up the descriptors.
Wait, okay, so it says the smallest variance is 7,180.75. That is not what I get if I do the
What's your smallest standard deviation?
22.551.
Yeah, I
Yeah,
see
that's
that.
what I got. But
And
it certainly
it's
isn't
not?
pulling it up.
No, it's not. So is it in the minimum? Do you think it's the
Let me
minimum?
see if I have that answer anywhere.
See, I think it might be the minimum. What does it say on the 7,000? Nope, not that. I got 7,396 with using the minimum value.
What about what about the lower bound? No, that'd be even more.
It wouldn't be that either.
Oh, no. Is it
I don't know how they get that.
whatever type or no, what's that either?
Okay, I'm gonna look in the book. Okay, well it says, no, that's just the rule. What is the variance?
I got it.
What?
It's the sodium numbers.
It's the sodium number. So if we don't do the calories, it's right.
Yeah, the lowest variant on the sodium is 84.739306. When I squared it, I got 7180.75.
Oh, perfect.
So it's just the sodium.
Just the sodium.
So the variance it says the VAR 30003. That's the sodium.
So
Oh yeah.
102.434716 squared. And that gives us the 10492.87104.
Perfect. Okay, so we did it right on the other one then. That's good.
If we used because it only had one option, one variable anyway, so. Okay, yep. I see that.
Okay. So what did you guys put for that one?
Oh yeah, because it says now let's examine sodium levels. Construct Q plots of the sodium levels. The smallest variance and the largest variance. Have the assumptions been met? So is this where we have to do the 4 divided times the smallest one by 4 and see if it's less
I think
than that number?
Well, that and the QQ plots that it's talking about.
A possible problem with the normality assumption, since have the assumptions been met? Okay, so
are normal.
that isn't the QQ plot normally distributed, and then the other one has to be that the smallest variance is 4 times whatever that rule is.
Yeah.
Less.
So my Q plots were normal, but then it's not less than 4 times the lowest. So I put the third one.
No, that is not safe. But we can assume that the variances are equal? I don't get that.
I don't get that part either. I just put it because
So if we divide 10492.871 by 4, is that what we're supposed to do?
I multiplied the smallest one by 4, and it's 28,723.
yeah.
So it's a lot larger than the largest number.
Wait, hold on. The rule is
I'm like going back. So the largest variance is less than.
okay. So then it has met them because the QQ plot is normal and it's less time.
Yep.
And it's what?
So I think it's the first one. It's less than 4 times the lowest variance, and our QQ plots are
Well, it's not-
normal.
Okay.
So I think the assumptions have been met. It's okay to assume each group comes from a normally distributed population, and also the variances are equal.
Okay. All right, and then question 17. Despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all 3 groups. What's the p-value for this test? And it's 0.179.
Yeah, that's what I got.
And then
But it's just
question,
the value for all of them.
let me look it back up.
I'm trying to pull it up.
What did you ask?
Oh yeah, I see it. Okay, yep.
You got it?
Yeah.
Okay, so then the next one, since our p-value is 0.179, is greater than the level of significance, which means we do not reject the null, which then means we have sufficient evidence to claim that all 3 candidates have the same mean sodium levels.
So which one?
The first one.
No, wait.
Because we did not reject the null. And the null means that all of the means are the same.
Yeah. Okay, yeah, I see that. I get that.
Do you guys agree? I don't.
For some reason, I put the second one. But these are the parts I had hardest trouble with.
I just had to try to talk myself through it. So if the p-value is low, then you reject the null. But the p-value is higher than the level of significance, so we do not reject the null. But the null, remember, is that all means are the same. So when you don't reject the null, then we agree that all means are the same. Does that make sense?
But I think all of these say that they're all the same.
But you're right. Actually, I think you're right. We do not. Hold on. Let me see what it says.
Evidence to reject. Oh, that's worded differently than we've seen. We do not have sufficient evidence to reject the claim.
But it's right because I wrote that in my notes. That's how they word it. We have insufficient evidence.
I remember that too.
Why do they have to be so weird about it?
I don't know. Why is it different?
That's
So-
the thing. Like they say the same exact thing, they just
I know.
different. I don't understand why it matters.
Because it proves to them that we are understanding the logic and reasoning even when we don't.
Right.
Maybe because
Or at least-
the Nova one, like, and you can't be which one different means or whatever. So I don't know.
I don't know either.
It's such a hard thing for me to figure those out.
Yeah. But
But-
I'm glad you did because you're right. I had to go back and look at how they worded it in my notes,
Yeah.
and that's exactly.
I would have just thought the first one's right too until I read the second one.
Well, the first
And I
one
was like, oh yeah.
it says the same thing. That's what's so dumb about
Yeah, it's like the same thing, but worded differently.
Okay, I'm scared. Do you guys want me to submit it?
I'll submit it if you want me to.
You do it.
I'm
Okay,
nervous.
I'll do it.
You already have all your answers written down, don't you?
Not all of them. I have all but the last couple of them, or three of them, I think.
We can tell you if we need to.
All right, here we go. Submit. Submit. A 100.
Oh my
No way. Are you
We got
serious?
it.
Oh my god.
proud of ourselves.
Awesome.
So confusing. So I just have to remember the whole square, the smallest variance.
Yeah, I wrote it down because I didn't see that anywhere.
I didn't either. I don't even remember that.
I'm so glad you knew that, Becky.
Oh, thank you. That's
Yeah.
one of the few times I remembered something correctly.
Good job. Well, we needed it. So, okay. Cool.
All right.
Awesome, guys.
So, are we good?
Just be a review then, or Thursday for the test.
Yeah, Thursday night at 8:45 y'all's time.
Okay.
And we'll just try to do the best we can to practice. Was there a practice sheet or something in this?
Let me see.
I
There was,
looked for one. I didn't see one. I thought there was one last time, but I didn't see anything like that this time.
say that for this test we can use that kind of tree thing he had.
Y'all are breaking up. I can't understand you.
There's just that part in the online textbook is all I see.
There's an individual preparation.
Maybe that's all there is. That plus our group meeting, huh?
Yep.
Yeah.
All right. Well, good luck with studying and trying to figure out how to fit everything into your cheat sheet.
Yeah.
Yeah, that's the fun part.
Yeah. All righty.
Okay. All right.
Well, I'm going to copy the link. Here I'm copying.
Did you stop the broadcast?
Not yet. All right. I'm stopping the broadcast.